Started.
Okay.
Hello,
Hello.
Students, there is an audibility trouble. Kindly wait for some time. It is settling now. Kindly wait for some more time.
அப்போ வந்து சமையல் ரூம்ல வந்து
சார் ரொம்ப நேரம் ஆகுமா? குட்
Good
மார்னிங்
morning,
சார்.
sir.
Morning, sir.
குட் மார்னிங் சார்.
குட் மார்னிங் சார்.
Yes, sir.
Good morning, sir. Good morning, sir. Morning, sir.
Okay, sir. Okay, sir.
Sir. Yes, sir.
Yes, sir.
சார் கரெக்டாக தான் சார் கேட்குது.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, sir.
ஓகே
Okay,
சார்.
sir.
Yes, sir.
சார்.
Yes, sir.
Yes, sir.
எஸ் சார். கேட்குது.
Okay, sir.
ஓகே சார்.
Okay, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Okay,
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 sir.
sir.
Yes, sir. Start. Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, sir.
Okay, sir.
Okay, sir. Yes.
Hello, am I audible? அப்படியே அவர்கிட்ட கொண்டு போய் கொடுப்போம். குணா சார் இதுலயே பேசு. இதுலயே பேசு. அப்படியே மெதுவாக இருந்துச்சு. கழட்டி வச்சுக்கோ. அப்படியே பேசு. சார் கூடவே சொல்லலாம்.
Hello, students, shall we start the session? Students,
Yes.
hello?
Yes, sir. Yes, sir.
Okay, sir.
Yes, sir. Yes, sir.
Okay, ma. Please
Yes,
wait.
sir.
Okay. 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 So already we discussed it, the face value. The face value is okay. So already we discussed the face value. The number itself. The number. The number is. The number itself is called the face value. Next one is the place value. Next we go to the definition. Place value. The place value of the digit is multiplied by 10 power n, where n starts from 0. For example, if you take the same example, 331, the place value of 1 is 1 into 10 power 0. For any number, we have power 0, that value will be equal to 1. So 1 into 10 power 0 equal to 1 into 1 equal to 1. So the place value of 1 is 1. Similarly, the place value of 2 is 2 into 10 power 1. That is 2 into 10 equal to 20. The next one is the place value of 3 is 3 into 10 square. So that is equal to 3 into 100 is equal to 300. So this one is the place value of 3. The place value of 3 is 300. The place value of 2 is 20. The place value of 1 is 1. So in this way we can find out the place value of any numeral. We can find out place value of any numeral. You take another example. You take the same example, 5471. In this numeral 5471, the place value of 1 is 1 into 10 power 1. 10 power 0. The place value of 10 is 1 is 1 into 10 power 0. This is equal to 1 into 1. This is equal to 1. Similarly, the place value of 7 is 7 into 10 power 1. This is equal to 7 into 10. This is equal to 70. The place value of 4 is 4 into 10 square. This is equal to 4 into 100. This is equal to 400. Similarly, the place value of 5 is 5 into 10 power 3. This is equal to 5 into 1000. This is equal to 5000. So in this way, we can find out the place value of the numeral. The place value of the numeral. So this one is the place value and place value of the any numeral. Next we go to the types of numbers. These are the different types of numbers. The first one is natural number. The second one is whole number. Then third one is even number. The fourth one is odd number. The fifth one is prime number. Sixth one is composite number. And the seventh one is co-prime number. Then the eighth one is integers. Again, the integers are divided into 4 categories. Integers divided into 4 categories. First one is positive integers, negative integers, non-negative integers, non-positive integers. And the ninth one is real one is even number. The fourth one is odd number. The fifth one is prime number. Sixth one is composite number, and the seventh one is co-prime number. Then the eighth one is integers. Then the integers are divided into four categories. Integers divided into four categories. First one is positive integers, negative integers, non-negative integers, non-positive integers. Ninth one is real numbers. Ninth one is real number and 10th one is complex number. Now we go to the definition of each type of numbers. We go to the definition of each type of numbers. The first one is natural numbers. The natural numbers is denoted by the letter, capital letter N. All these concepts are already discussed in the school level. Natural numbers, the set of all numbers start from 1, 2, 3, etc. So this one is the set of natural numbers. The capital letter N is used to represent the set of natural numbers. The next one is whole numbers, all counting numbers together from 0 from set of whole numbers. Form a set of whole numbers. So W equal to the set of all numbers start from 0, 1, 2, 3, etc. This one is the set of whole numbers. Here one point is given. 0 is the only whole number and also which is not a natural number. This is one of the standard result in natural number and a whole number. 0 is only the whole number and the 0 is not a natural number. Next one is even number. A number which is divided by 2 exactly is called even number. Odd number, a number which is not divided exactly by 2 is called odd number. So also the capital letter E is used to represent the even number. Capital letter O is used to represent the odd number. The examples for even number are 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, etc. So these are the examples for even number. The examples for odd number is 1, 3, 5, 7, 9, etc. This one is the example for odd number. Usually capital letter O is used to represent the odd number. Next we go to the prime number and the composite number. First we see the definition of prime number. A number which has exactly 2 divisors is called the prime number. The divisors are the number 1 and the number itself. For example, randomly you take any number. Here I take the number 7. Now what are the divisors of 7? Then divisors means when you divide the number 7 by that number, you will get remainder 0. So that is the meaning for exactly divisible. So when you here I take an example for 7. Here, what are the divisors of 7? Anybody responds me? What are the divisors of number 7?
1 and 7.
1 and 7.
1 and 7. So the divisors of 7 are 1 and 7. So the 7 is prime number. A number which has exactly 2 divisors. What are the 2 divisors? The number 1 and the number itself. The number 1 and the number itself are the divisors. So such a numbers are called a prime number. So examples are given. The example for prime numbers are given. 2, 3, 5, 7, 13, 11, 13, etc. You take one more example. You take another number 9. What are the divisors of 9? What are the divisors? Any student, please reply me. What are the divisors of 9?
1,
139.
139. So this number 9 has how many divisors? 3 divisors. What are the divisors? 1, 3, 9 are the divisors of 9. So 9 is not a prime number. So it is a composite number. So that is the difference between prime number and a composite number. A number which has exactly 2 divisors is called a prime number. A number which has more than 2 divisors are called composite number. The example of prime number and a composite number mentioned in your slide. We can find plenty of examples for prime number and a composite number. Like that, we can find out plenty of examples for prime number and a composite number. Okay, randomly you take any number, you identify the divisors. So based on the divisors, we can find out the given number is prime number and a composite number. Okay, so this one is the definition of prime number and a composite number. Okay, are you clear? Are you clear, students? Please reply me.
Yes, sir.
Okay.
Yes, sir.
Next, what about the number 1? What about the number 1? The number 1 is either prime or composite number. So that is given in a note. The number 1 is neither prime nor composite. 1 is not a prime. The number 1 is not a prime and also not a composite. It is unique. It is unique. The number 1 is, that is the first point in the note. The number 1 is neither prime nor composite. It is unique. The second point is, in the case of even numbers, all the even numbers are composite number except number 2. The first even number 2, which is only prime number, remaining all the even numbers are composite number. Okay, that is mentioned. 2 is only even prime number. The number 2 is only even prime number. The remaining all the even numbers are composite number, because except this 2, remaining all the even numbers has more than two divisors. So this one is composite number. Then third one is, there are 25 prime numbers between 1 and 100. There are 25 prime numbers between 1 and 100. So these are the some standard results based on the prime number and the composite number. Okay, next we go to the next type, next definition, co-prime number. Now the definition of co-prime is, two numbers or A and B are said to be prime number if their highest common divisor is 1. You take randomly any two numbers, you find out highest common factor or greatest common divisor. Highest common factor or greatest common divisor of that two numbers. If the highest common factor is 1, then that two numbers are co-prime. So example for co-primes are 2, 3. 2, 3 are co-primes. So highest common factor of 2 and 3 is 1. Similarly, another example for prime number is 4, 5. Highest common factor of 4 and 5 is 1. So 4 and 5 are co-primes. Next, integers. Now, usually the set of integers is represented by capital Z. N is greater than or equal, now you go through the definition. N is greater than or equal to 0 or less than or equal to 0, where N is a counting number, -3, -2, -1, 0, 1, 2, 3, etc. Now, the integers are again classified into 4 types. The integers are classified into 4 types. The first one is positive integers. The second one is negative integers, non-positive integer, non-negative integer. Now, the positive integers, what is positive integers is purely greater than 0. 1, 2, 3, etc. Positive integers. Negative integers, it is purely less than 0. -1, -2, -3, etc. Non-positive integers. Now you identify the difference between positive integers and non-positive integers. In the positive integers, 0 is included. In the positive integer, 0 is included. In the non-positive integers, in positive integers, 0 is not included. In positive integers, 0 is not included. In non-positive integers, 0 is added. Now you, 0 is added. So what is the non-positive integer? 0, -1, -2, -3, etc. Similarly, non-negative integers, 0, 1, 2, 3, etc. So in the case of non-positive integers or non-negative integers, 0 is added. 0 is neither positive nor negative integer. So 0 is non-positive integer, also non-negative integer. 0 is neither positive nor negative integer. Okay, so this one is the definition of integers and the 4 categories of the integers. Next one is real numbers. A real number is any positive negative number. This includes all integers and all rational and irrational. Rational numbers, below that we give the definition of rational number. Rational numbers are numbers that can be expressed as fraction or part of the whole number. So example for rational number is given. -7 is one example of a rational number. 2/3 is another example for rational number. 3.75 is also another example of rational number. So this one is the example of a rational number, and irrational numbers are the irrational numbers are numbers that cannot be expressed as a fraction or a ratio of two integers. There is no finite way to express these numbers. Examples for irrational numbers are √2, √3, and pi. What is the value of pi? Anyone reply me? What is the value of pi?
3.14.
3.14 or 22/7. 22/7, 3.14. This is the example for irrational number. So 22 by 7, 3.14 is irrational number, root 2, root 3. So all these are example for irrational numbers. So usually irrational numbers are represented by using the capital letter Q. Irrational numbers are represented by using the capital letter Q, and the set of real numbers are represented by using the capital letter R. So these are the example for rational numbers and irrational numbers. The definition also discussed there. The finally complex number. Already you know the definition of complex number. Any number which can be written in the form of a plus ib. Any number which can be written in the form of a plus ib is called complex number, where a and b are respectively called real and imaginary part. Example for complex numbers is 3 plus 2y and 5 minus. You write your own example. Here I gave the example 3 plus 2y and comma 4 minus 5y. You don't follow this example. You take your own example. Randomly you take any example. For sample, I gave 2 examples for the complex numbers. So these are the different types of numbers. These are the different types of numbers in number system. And all these number system, we discuss the examples also. Next one is divisibility test. So by using this divisibility test, we can identify whether the given number is exactly divisible by 2. What is the meaning of exactly divisible by 2? Randomly, exactly, what is the meaning of exactly divisible? Anyone reply me? What is the meaning of exactly divisible? Suppose randomly you take one number 547. A remainder is 0. A number is divided by another number. If we get a remainder 0, then we say that that number is divided by this number exactly. That is the meaning for exactly divisible. So here we discuss a divisibility test. So suppose randomly give one number, randomly give any one number, how to identify this number is exactly divisible by 2? Some test is available. By using this test, we can identify this number is exactly divisible by 2, this number is exactly divisible by 3, this number is exactly divisible by 4, etc. So by using this test, suppose a number is given, we can using this test, we can check the given number is exactly divisible by 2, this number is exactly divisible by 3, etc. So divisibility by 2. So already you know this, a number is exactly divisible by 2 if its unit digit is 0, 2, 4, 6 or 8. If unit digit lies any one of these numbers. If unit digit is any one of these numbers, then that number is exactly divisible by 2. Example is given 25,436. First example is 25,436. Here unit digit is 6. So this number is exactly divisible by 2. The next number is 43,287. Here unit digit is 7. So the unit digit is even number. The unit digit is even number, then that number is divisible by 2. So 43,287. Here the unit digit is 7. So this number is not divisible by 2. So this one is divisibility test for 2. Next one is divisibility by 3. Suppose given one numeral. Suppose I given a numeral, how to identify that numeral is exactly divisible by 3 or not? So that can be identified by using this test. You add all the digits appeared in the numerals. Then find divide the summation by 3. So the summation is exactly divisible by 3. Then the whole number is divisible by 3. Otherwise it is not divisible by 3. Suppose randomly you take one example 64,578. In example 1, you go through that 64,578. Now you in this numeral add all the numbers 6 plus 4 plus 5 plus 7 plus 8. When you add all the numerals, the sum is 30. So this 30 is divisible by 3. When you add all the digits appear in the numeral. So in this example, the digits are 6, 4, 5, 7, 8. Add all the numerals 6 plus 4 plus 5 plus 7 plus 8. When you add all the digits, the total sum is 30. So this 30 is divisible by 3. So the numeral 64,578 578 is divisible by 3. So this one is divisibility by 3. Similarly, go to second example 54,371. You add all the numbers 5 plus 4 plus 3 plus 7 plus 1. When you add all the digits which are appeared in this numeral, the total sum is 20. The 20 is not divisible by 3. So the whole numeral is not divisible by 3. So this one is the divisibility by 3. Next one is divisibility by 4. Next one is divisibility by 4. In a number, the last two digits is divisible by 4, then the whole number is divisible by 4. In a given numeral, last two digits are divisible by 4 then the whole number is divisible by 4. Whole number is divisible by 4. Now you go to the first example, 64,578. So in this 64,578, last two digits of 78. Last two digits of 78. 78 is divisible by 4. The whole numeral 64,578 is divisible by 4. Come to second example, 56,431. So in this 56,431, last two digits are 31. 31 is not divisible by 4. So we have the whole number 56,431 is not divisible by 4. So this one is divisibility by 4. Next one is divisibility 5. So a number which is divisible by 5, if its unit digit is 0 or 5, the unit digit is 0 or 5 appeared, then the whole number is divisible by 5. You take the first example, 760. So in this 760, the unit digit is 0. The unit digit is 0. The whole number 760 is divisible by 5. Come to second example, 541. In this numeral 541, the unit digit is 1. So 500. So from this we conclude that as per the divisibility test for 5, we conclude that 541 is not divisible by 5. So this one is divisibility by 5. Next one is divisibility by 6. A number which is divisible by 2 and 3 are apply means then that number is divisible by 6. A number which is divisible by 2 and 3, then it is divisible by 6. This one is one of the divisibility rule that we'll discuss in the later. Divisibility rule. A number which is divisible by 2 and 3, then the number is divisible by 6. You take the same example, 64,578. 64,578. So this number 64,578, which is divisible by 2 and also divisible by 3. This number 64,578, which is divisible by 2 and also divisible by 3. So as per the condition of divisibility by 6, the whole number 64,578 divisible by 6. So this one is divisible by 6. Next one is divisibility by 9. So divisibility by 8. Divisibility by 8 in a given numeral, last three digits are divisible by 8 then the whole number is divisible by 8. So this one is divisibility by 8. In a divisibility test, last three digits are divided by 8, then the whole number is divided by 8. You take the same example, 64,578. Here the last three digits are 578. Here 578 is divisible by 8. So the whole number 64,578 is divisible by 8. So this one is divisibility by 8. Next one is divisibility by 9. The divisibility by 9 is same as the divisibility by 3. What is the condition for divisibility by 3? The sum of all the digits in a given numeral, you add all the digits, the total sum is divided by 3, then the whole number is divided by 3. The same concept applied in divisibility by 9. You add all the numbers, the total sum is divided by 9, then the whole number is divided by 9. Take an example 64,579. You take an example 64,579. You add all the numbers 6 plus 4 plus 5 plus 7 plus 9. The total sum is not divisible by 9. The total, you add all the sum. What is the summation for 6 plus 4 plus 5 plus 7 plus 9? Anybody tell me the summation for the divisibility by 9? Or you the example, you tell me the summation of that numeral. 6 plus 4 plus 5 plus 7 plus
31.
9. Huh? What is the summation, ma?
31. 31.
Huh? I'm not here. 31. So 31 is not divisible by 9. 31 is not divisible by 9. So the whole number 64,579 is not divisible by 9. So this one is divisibility by 9. Next one is divisibility by 10. That is already very, if unit digit is 0, then the whole number is divisible by 10. Example, 3,458, a unit digit is 8. So this number is not divisible by 8. Next one is divisibility by 11. Divisibility by 11, a number is divisible by 11 if the difference between some divisibility by 11, a number is divisible by 11 if the difference between sum of digits at odd places and sum of digits at even places is either 0 or is divisible by 11. So this one is the divisibility by 11. I will explain this divisibility test of 11 by one example. You go to the example 64,575. 64,575. We have to check this number 64,575 is divisible by 11 or not. For that, you find out the sum of the digits which occurs in odd places. Sum of the digits which occurs in odd places. Now in the example also mentioned, what are the digits which occurred at odd places in this example 64,575? The digits which are occurred 6 plus 5, 655. We are all, so you add all these digits 6 plus 5 plus 5. So these are the digits which are occurred in odd places. And what are the digits which occurred in even places? What are the digits which occurred in even places? What are the digits in that example? Which digits which are which digits which occurred in even? I'm not here. 4 and 7. 4 and 7. 4 and 7. The digits which are occurred in odd places are 6, 5, 5. The digits which are occurred in even places are 4 and 7. So add the numbers. Add all the odd places digits. Add all even places digits. 6 plus 5 plus 5 and 4 plus 7. You find the difference. 6 plus 5 plus 5. What happens? 16. 16 minus 11. 5. So 5 is not divisible by 11. So the whole number is not divisible by 11. Okay, so this one is divisibility. So this one is divisibility for 11. This one is divisibility test for 11. Okay, are you able to understand the divisibility test for 11? Here, for all divisibility test, randomly I give one example. You apply this divisibility test for any number. You apply all this divisibility test for any number. Okay, for each divisibility test, randomly I gave one example. For your understanding purpose, I gave example for each divisibility test. Okay, shall we go to next topic?
Yes, sir.
Shall we go
Yes, sir.
next topic?
Yes, sir.
Okay. Next, prime number test. Suppose given one number, randomly given a number, how to check whether the given number is prime number or a composite number? Randomly, a prime. Next we discuss prime number test. Randomly a number is given. Randomly a number is given. We have to check whether the given number is prime number or composite number. By identifying the devices, as per the definition of prime number and a composite number, by identifying the devices, we conclude that whether the given number is prime number or a composite number. That is one method. But largest number, but for 3-digit number, it is difficult to find out the devices. For 3-digit number and 4-digit number, it is difficult to find out the devices. So in this case, we can use this method to identify whether the given number is prime number or composite number. Okay, suppose I will explain this prime number test with an example. You can understand easily. The definition is if I dictate that the procedure, you are very difficult to understand. So I will explain this test with one example. So you randomly you take one number 137. Randomly you take a number 137. Here I'm going to check this number 137 is prime number or composite number. As per the definition, by using the definition, we can identify by finding the devices of this 137. 137 is prime number or composite number. That is one method. It is difficult to check whether the given number is prime number or composite number. So by using this shortcut method, we can identify whether the given number is prime number or composite number. For that, first you find out square of one number that is greater than this 137. That is greater than nearest greatest number to this 137. In that example I mentioned 12 square. 12 square is 144, which is this number 144 is nearest greatest number, the square, perfect square. Nearest perfect square of this 137. What is the meaning of perfect square? Anybody tell me what is the meaning of perfect square? Anybody tell me what is the meaning of perfect square?
Square of the number.
Square of, if you find out the square of any number, you'll get a whole number. You will not get a decimal number. If you find out a square root of any number, you should get a decimal number. What is square root of 3? What is the square root of 3? 1.732. So 3 is not perfect square. 3 is not a perfect square. Now suppose you take a square root of 4. What is the square root of 4? 2. So you will get whole number. So 4 is perfect square. 4 is perfect square, but 3 is not a perfect square. But 3 is not a perfect square. So there is a difference between perfect square and not a perfect square. So you have to, that is the concept here. So for this 137, you find out nearest perfect square of this 137. Nearest perfect square, and also this perfect square should be greater than 137. You find out greatest near greatest perfect square of 137. So 12 square is 144, which is nearest greatest perfect square of 137. That is main concept. Nearest greatest perfect square. That is the main concept to find in this prime test. So 12 square, 13 square is also 169. That is also greater than 137, but you don't take that number. Okay, that is the concept. You find out nearest perfect square and also which is greater than this 137, 12 square. Next, you find out the prime numbers which are less than 12. Now, what are the prime numbers less than 12? What are the prime numbers less than 12?
2, 3, 5, 7, 11.
2, 3, 5, 7, 11. So these are the prime numbers. Now you identify if any number among these 5 numbers, any number divide 137. If any one number divides this 137, P is not a prime. If any number divide this number, P is a prime. If any one number divide this 137, P is not a prime. If no number divide this 137, P is a prime. Now, by using this concept, totally you have 5 prime numbers for this 12. Totally you have 5 prime numbers less than 12. So the 5 prime numbers are 2, 3, 2, 3, 5, 7, 11. 2 divides 137. 2 divides 137. You please reply me.
No, sir.
No.
No,
3
sir.
divides 137.
No, sir.
No. 5 divides 137.
No, sir. No.
No. 7 divides 137.
Yes.
And also 11 divides final prime number. 11 divides 137. No. So
sir.
no numbers. So no prime numbers divide this 137. So from this we conclude that 137 is a prime number. Are you able to understand?
Sir.
If any one number, so that means no number means the number which are less than 12. Totally you have 5 prime numbers. Among these 5 prime numbers, no number less divide this 137. No number divide this 137. So from this we conclude that 137 is a prime number. If you any one number among these 5 numbers, if any one number divide this number 137, then we say the 137 is a composite number. So we say 137 is a composite number. Below that, we have I had given four more numbers. Below that, I had given four more numbers. So among the 4 numbers, you randomly take any number. Randomly you take any number. You check whether the given number is prime number or composite number. So shall we go to an example for this prime test? Shall we go to, for your understanding purpose, we'll discuss one more example. Mostly all the students are understood that the prime test, for better understanding purpose, we'll take one more example for the prime test. So among the 4 numbers, you take any one number. Anybody tell one number? Among the 4 numbers, anyone tell me one number? 811. 811. For this 811, you find out nearest perfect square, and it should be greater than 811. And it should be greater than 811. Anybody tell me? Nearest perfect square, and also you should be greater than 811. Anybody tell me perfect square number? I need perfect square. When you take the square root of that number, you will get whole number. You will not get decimal number. Like that, you tell me the number. 811, nearest perfect square, and it should be greater than 811. Anybody? 20 square, 25 square greater than 26 square. 30 square pota, you'll get
29, sir.
29. What is 29 square?
841.
841. Okay, very good. 29 square, 841. Next, you identify the prime number. You write down the list of prime numbers which are less than 29. You write down the list of prime numbers which are less than 29. One is prime number. One is prime number.
No, sir.
No, one is not a prime number and also not a composite number. It is unique. Now you tell me the list of prime numbers which are less than 29. You tell me the list of prime numbers which are less than 29. Anybody tell me?
2, 3, 5, 7.
2, 3, 5,
2, 3,
7,
5, 7, 11, 13, 17,
13, 15 is not a prime number.
No, sir.
15 because 15 has 3 devices, 1, 3, 5. 15 is not a prime number. Okay, 16 is also not a prime number. 16, 17,
19,
19, 21 is not a, 20 is not a prime number. 20 is not a prime number. 21 is not a prime number. 22 is also not a prime number. 23, what happened? 23.
Prime number. 23, 29.
23 prime number. 24.
27,
Gradually come one by one. Don't skip the numbers. Gradually come one by one. 23 is not a prime number. What about 20? What about 24?
It's not a prime number.
20 not a prime number. 24 is not a prime number. 25 not a prime number. 28, 27, 29. After 23, we have 29.
29.
Okay, right. Now you check. Totally we have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 prime numbers. You identify among these 10 prime numbers, any number divide 811. You add among these 10 prime numbers, you identify if any prime number divide this 811. If any number 2 does not divide 811. 3 divide 811. 3 divides 811.
No, sir.
No. 4, 5 does not divide. 7 divides 811. No. 11 divides 811.
No, sir.
Just you calculate and tell me. Students are requested to, that's why I gave the information. Students are requested to attend with paper and pen. That just you do the calculation and tell me whether it is exactly divisible or not. So 11 is not possible. 13?
No, sir.
Please do the calculation and tell me. No. 17?
No, sir.
19?
No, sir.
23?
No, sir. No, sir.
29?
No, sir.
So no prime number divide this 811. No prime number divide this 811. So
So it is a
811 is a prime number.
prime number.
811 is a prime number. If any one prime number divide this 811, then we conclude that 811 is a composite number. This one is prime test. This is one of the shortcut method to identify whether the given number is prime number or composite number. Okay. Next, division algorithm. The division algorithm is very simple. This division algorithm already studied in school level. So division algorithm is dividend equal to divisor into quotient plus
Plus
remainder.
reminder.
Okay, this one is division algorithm. I will explain this division algorithm with an example. Suppose you divide 27 by 6. But students are requested to write in division manner. When you divide 27 by 6, you will get 4 times of 24. You will get remainder 3. So in this example, 27 is called dividend. All these are mentioned in your slide. 27 is dividend, 6 is divisor, 4 is quotient, and 3 is remainder. Okay, all these are mentioned there. In the division procedure. In the division procedure, all students are understood which one is dividend, which one is divisor, and which one is quotient, and which one is remainder. Okay, so this one is division algorithm. Shall we go to next topic? This one is division algorithm. Next, there is one shortcut method how to find out greatest n-digit number which is exactly divisible by number. To find out greatest n-digit number which is exactly divisible by another number. Suppose a greatest n-digit number exactly divisible by a divisor is obtained by subtracting the remainder from the given number. Subtracting the remainder from the given number. Suppose you follow the example, find the greatest 3-digit number and greatest 4-digit number. Find the greatest 3-digit number and 4-digit number which is exactly divisible by 13. Find the greatest 3-digit number, greatest 4-digit number which is exactly divisible by 13. So I will explain this example with the solution. Go to the solution. Greatest 3-digit number is 999. When you divide 999 by 13, you will get the remainder 11. You will get the remainder 11. Subtract this remainder from 999. So subtract this remainder from 999. You will get 988. So this one is greatest 3-digit number which is exactly divisible by 13. Similarly, we find out the greatest 4-digit number which is exactly divisible by 13. We follow the same procedure. Are you able to find out the greatest 4-digit number divisible by 13? We follow the same procedure. Greatest 4-digit number and what is the greatest 4-digit number? 9,999. Greatest 4-digit number is 9,999. When you divide this 9,999 by 13, you will get some remainder. You subtract this remainder from this number 9,999, you will get one number. So that number is greatest 4-digit number exactly divisible by 13. Okay. So this one is the procedure to find out greatest n-digit number exactly divisible by a number. Okay. Next one is least n-digit number exactly divisible by a number. Least n-digit number exactly divisible by a number. So that is the procedure. A least n-digit number exactly divisible by a number by a divisor. D is obtained by adding divisor minus remainder to the given number. Example, find the least 3-digit number and the least 4-digit number which is exactly divisible by 13. So we follow the procedure. Least 3-digit number is 100. When you divide 100 by 13, you will get the remainder 9. Now you add what is the concept? Divisor minus remainder. Here, what is the divisor? 13. What is the remainder? 13. So 13 minus 9, you will get 4. That 4 is added to the number 100. add the number divisor minus remainder to the given number. Here the divisor minus remainder 13 minus 9 equal to 4. So you add this 4 to this 100, you will get 104. So this one is least 3-digit number which is exactly divisible by 13. Similarly, we can find out a least 4-digit number which is exactly divisible by 13. The same procedure we follows. What is least 4-digit number? What is 1000? Least 4-digit number is 1000. Divide this 1000 by 13, you will get some remainder. You subtract this remainder from the divisor 13, you will get a new number. You add that new number to this 1000. So you will get again a new number. That new number is least 4-digit number divisible by 13. So this one is procedure to find out a least n-digit number. Okay.
Sir,
Tell me.
the slide is not visible, sir.
Slide not, Professor. Sir, Perisami sir. Slide not visible among them. முடிச்சிடலாம் சீக்கிரம் வாங்க. Slide not visible வர்றா.
வீட்ல இருக்கிறவங்க செக் பண்ணுங்க. இந்த பேஷன்ஸ் நீங்க செக் பண்ணுங்க உங்களுக்கு தெரியா?
Students, are you view the slide?
No, sir. No, sir.
No, sir.
No, sir.
No, sir.
அவனுக்கு தெரிய மாட்டேங்கிறான். நம்மளோட பிபிடி இதை மூவ் பண்ணி பாருங்க. ஆகுது. Students, are you view the slide?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
Students, are you able to view the slide?
Yes, sir.
Yes, sir. Yes, sir.
Okay, ma. Okay.
No, sir. Till now I can't see the slide, sir.
What, ma?
No, sir.
Are you able to view the slide? Hello? Any please students reply? Huh?
Yes, sir.
Yes, sir. I can see
Okay. Shall we continue the session?
Sir.
Okay, so just we discussed least n-digit number exactly divisible by another number. So for example, we discussed find the least 3-digit number and 4-digit number which is exactly divisible by 13. The least 3-digit number is 100. When you divide this 100 by 13, we'll get the remainder 9. That is mentioned in your slide. We'll get the remainder 9. You subtract this remainder from the divisor. Here divisor is 13. and the remainder is 9. So divisor minus remainder 13 minus 9 equal to 4. You add this 4 to this given number 100. So 100 plus 4 is 104. So this one is least 3-digit number which is exactly divisible by 13. This is one example. Like this, you apply this test for any example. You can find least 5-digit number which is exactly divisible by 15. You follow the same procedure. You can find a least 4-digit number which is exactly divisible by 11. So this is for randomly I gave one example. Okay, so you apply this test for any example. Okay, so you go to second example. What is the least 4-digit number? 1000. When you divide 1000 by 13, what is the remainder? Anybody tell me? Please do the calculation and tell me. Don't tell randomly. When you divide 1000 by 13, what is the remainder? Anybody tell me? Please do the calculation and tell me. Are you able to hear? When you divide 1000 by 13, what is the remainder? 7 13s are 91. 9 90. What is the remainder, ma? Are you able to hear? Students, huh? What is the remainder? What is the remainder? What is the remainder? When you divide 1000 by 13, what is the remainder?
76.
The remainder 76 is quotient. 76 is quotient. The remainder, the last. What is the remainder?
25.
Wrong. 20.
12, sir.
12. So remainder is 12. Correct. So when you subtract this remainder. Okay, you please students, please follow. You subtract this remainder from the divisor. 13 minus 12. 13 minus 12 is 1. So you add this 1 to this 1000. Add this 1 to 1000. What happened? 1001. So the least 4-digit number. The least 4-digit number which is exactly divisible by 13 is 1001. Okay.
1000.
Okay, are you able to understand? 1001 is the least 4-digit number which is exactly divisible by 14. Like that you can find out any number. Okay, next one is general properties of divisibility. Totally there are 4 properties of divisibility. The first one is if a number x is divisible by 2 or more numbers and also these numbers are co-primes, then the whole number is divisible by the product of these numbers. That one is property 1. If a number x is divisible by 2 or more numbers, all these 2 or more numbers are co-primes, then x is divisible by product of these numbers. For example, 2520 is divisible by 5, 4 and 13. And also these 3 numbers 5, 4, 13 are co-primes or prime to each other. Then 2520 is divisible by 5 into 4, 20 and 65, 5 into 13 and also divisible by 42, 13 into 4. That is the first property of divisibility. If a number x is divisible by 2 or more numbers and also these 2 or more numbers are co-primes, then x is divisible by the product of these numbers. For that I give an example, 2520. All this number 2520 is divisible by 5, 4 and 13. Divisible by 5, divisible by 4 and also divisible by 13. And also all these 3 numbers are co-primes. So this number is divided by 20 and divided by 65 and divided by 42. 20 is 5 into 4, the product of 2 numbers 5 and 4. And divided by 65, this is product of 5 and 13. And divided by 42, this is the product of 13 and 4. Next, property 2. If two numbers x and y are divisible by p, then x plus y is also divisible by p. This is property 2. Here 72 and 84 is divisible by 4. So 72 plus 84 is also divisible by 4. This is property 4. 72 is divisible by 4 and 82 is divisible by 4. So 72 plus 84, the summation is also divisible by 4. This one is property 2. Next, property 3. If two numbers x and y are divisible by p, then the difference is also divisible by p. You take the same example. 72 is divisible by 4, 84 is divisible by 4, then the difference 84 minus 72 equal to 12. It is also divisible by 4. That is property 3. Next to property 4. If a number x is divisible by another number y, then any number divisible by x will also divisible by y and also by all the factors of y. For that, I gave one example. The number 24 is divisible by 6. The number 24 is divisible by 6. Then any number that is divisible by 24. The number divisible by 24 that is given in the bracket 48 is divisible by 24. 72 is also divisible by 4. Like that we can find many numbers. Then these numbers will also divisible by 6 and also divisible by factors of 6. What are the factors of 6? These numbers, what are the these numbers? These numbers represents 48 and 72. This 48 and 72 are also divisible by 6 and these numbers 48 and 72 will also divisible by 2 and 3. So this one is divisibility test, divisibility rule, fourth divisibility rule. This one is fourth divisibility rule. These are the four general properties of divisibility. These are the four general properties of divisibility. Next, discuss some standard formulas which are used to find the sum of some natural numbers. Already you know this formula. The formula to find out the sum of the first n natural numbers. To find the sum of the first n natural numbers, we use the formula n into n plus 1 by 2. Next, to find the sum of the first n odd numbers, the formula is n square. To find the sum of the first n even numbers, n into n plus 1. To find the sum of the squares of the first n natural numbers, n into n plus 1 into 2n plus 1 by 6. The sum of the cubes of the first n natural numbers, n into n plus 1 by 2 the whole square. Now, from the formula 1 and 5, we conclude that sum of the cubes of the first n natural numbers. What is the relationship between the formula 1 and formula 5? Anybody tell me? What is the relationship between the formula 1 and formula 5? The sum of the cubes squaring. The squaring sum of the first n natural numbers, that will be equal to sum of the cubes of the first n natural numbers. That is the relationship between the formula 1 and 5. By using these formulas, we calculate these examples. For each formula, I gave an example. The first one is the sum of the first n natural numbers. The second one is sum of the first 8 odd numbers start from 1. The next one is sum of the first 9 even numbers start from 2. The fourth one is the sum of the squares of the first 30 natural numbers, that is 1 square plus 2 square plus 3 square plus etc. plus 30 square. Then fifth one is to find the sum of the cubes of the first 50 natural numbers. That is to find 1 cube plus 2 cube plus 3 cube plus etc. plus 50 cube. By using the formulas which is discussed in the previous slide, we calculate all these values. Students are requested to take all these 5 examples as assignment. Okay, formula is given, and also the examples are given. Students are requested to take all these examples as assignment. Suppose to find the sum of the first n natural numbers. So what is the formula? N into n plus 1 by 2. Here, what is the value of n here? What is the value of n here? For the first example, what is the value of n?
25.
25. Value of n equal 25. So what is the solution for the first example? 25 into 26 by 2. The solution for the first one is 25 into 26 by 2. So this one is the example solution for the first one. Similarly, do the remaining examples. Next one. This one is last one. Okay, next. Number of zeros. The next, this one is last topic. Number of zeros at the end of the product. Suppose given some numbers, you multiply all the numbers. You multiply all the numbers. So in that resulting number, how many zeros appear at the end of the product? That can be calculated by using the shortcut method. On multiplying, just you go through the slide. On multiplying two or more given numbers, the zeros are produced at the end of the resulting product. Can be obtained by using the following procedure. The first step is resolve all the given numbers into factors. Resolve all the given numbers into their factors and count the number of twos and zeros in these factors and number of zeros at the end of the product equal to number of twos or number of zeros. Which one is less? If number of twos are less na, the number of twos represent the number of zeros. If number of fives are less na, the number of fives represent the number of zeros. So this can be discussed in an example. You consider the number 15 into 32 into 25 into 22 into 40 into 75 into 98 into 112 into 125. When you multiply all these numbers, definitely you will get a very big number. In that very big number, you'll have some zeros at the end of the resulting number. At the end of the resulting number, definitely you have some zeros. We can identify how many zeros appeared in that resulting number by using the shortcut method. By using the shortcut method, we can identify how many zeros appeared in the resulting number at the end of the at the end of the product. All the zeros are appeared at the end of the product. Okay, so that can be calculated by using the procedure step by step. First you resolve into factors. Resolve into simple factors. That is 15. First number is 15. 15 can be written as 3 into 5. First 15 can be written as 3 into 5. Just you write down the product of 2s and 5s. Better you write the product of 32. How to write over 5? 32 can be written as 2 power 5. Next to 25. How to write 25? 25 can be written as 5 square. Next to 22. 22 can be written as 2 into 11. Better you write the product of 2 and 5. Next to 40. How to write 40? 40 can be written as 8 into 5. Again, this 8 can be written as 2 power 3 into 5. Next to 75. How to write 75? 75 can be written as 5 cube. 75 can be written as 5 cube. Next one is 98. 98 can be written as 2 into 49. Then next one is 112. How to write 112? 112 can be written as, you write in linear factors. 2 into, you write the linear factors of, write the linear factors of 2s and 5s. Here 112 is written only in the linear factors of 2. When you write 112 in linear factors of 102, anybody tell me how to write 112 in a linear factors of 2? 2 into 56. Again 56 can be written as 2 into 28. Again 28 can be written as 2 into 14. Again 14 can be written as 2 into 7. So this is equal 2 power 4 into 7. 112 can be written as 2 power 4 into 7. Come to the last number, 125. How to write 125? That can be written in the product of 5.
5 cube.
5 cube. Here, 75 is given. How to write 75? 75 can be written as 5 square into 3. How to write 75 is given number no. 75 can be written as 5 square into 7. Now, in this linear factors, count number of 2's and count number of 5's. How many 2's appeared in linear factors? How many 2's? One student count number of 2's and one student count number of 5's. Please tell me number of 2's and number of 5's. How many 2's appeared in the linear combination of linear product of all the numbers? Linear product of all the numbers. First we count number of 5's. Number of 5's la 15 we have 1 5. 15 la number of 5's la students requested to follow me. In number of 5's la 15 we have 1 5. In 22 we don't have any 5. In 25 we have how many 5's? We have 2 5's. Next, in 22 we have no 5's. In 40 we have how many 5's? In 40 we have how many? 1. Next, in 75 we have how many 5's? 2. Sorry, okay, right. Next is 75. In 98 we don't have any 5's. In 112 we don't have any 5's. In 125 we have how many 5's? 3. So totally we have how many 5's?
9.
9. Totally we have how many 5's? Similarly you find a number of 2's.
14.
Similarly you find a number of 2's. Similarly find a number of 2's. How many 2's? 14. Number of 2's or 14? Huh? 14. Number of 2's or 14? Students are count and tell me. Number of 2's or 14? So here 9 is less than 14. So here the number of zeros appeared in the resulting product is 9. Number of zeros equal to 9. Okay. So these are the sum topics. These are the sum topics in number system. We have plenty of topics in number system. We discuss only very small amount, a very small amount of topics discussed in number system. If time permitted, we discuss the remaining topics. Okay, in future. Okay, now.
Thank you, Professor. And here I am to do a vote of thanks. Thank you for your nice presentation on number system. We are grateful for the time and the effort you took to share your thoughts and experience with the number system. I strongly believe that our students can benefit immediately from your presentation. And please accept our sincere appreciation for the outstanding presentation you made on number system. And thank you for your patience. Thank you all.